I bid a warm welcome to you all who have joined with us today for attending this seminar by an eminent soil scientist, Director, CTCRI, Thiruvananthapuram. I would also like to offer my regards to Dean BGS for making this seminar functional. I welcome you, sir. Here with us we have our Dean, Dr. P.P. Mahendran, Asian Darai Madurai. He is with us to organize this function and to give introductory remarks. He is our support and power in organizing all the activities. I welcome you, sir, for this seminar. I welcome Dr. Saravana Pandian, Professor and Head, NRM, Horticulture College and Research Institute, Trichy, for having come for this seminar. And I welcome all the staff and students of Asian Darai Madurai. It's my pleasure and privilege to welcome our chief guest, Dr. Byju, Director, Central Tuber Crops Research Institute, Trivandrum. He has come over here for conducting the public defense of Mr. David, PhD scholar, whose chairman is Dr. Saravana Pandian. Sir, it's really a happy occasion to have him here, sir, for evaluating both the thesis and also for giving a special lecture during the seminar. We have come all the way from Trivandrum. We are present here offline to discuss with our students, to interact with our students. And this is a very great opportunity for us to hear from you our experiences, your experiences. So I welcome you, sir, on behalf of our staff and our department. And here, once again, I welcome all the staff and students who have joined with us today to hear this seminar. Thank you.
Most respected Dean SPGS who joined online. Respected guest speaker Dr. Byju, Principal Scientist and Director of CTCRI Thiruvananthapuram, Head of the Department Soils and Environment, Asian Darai Madurai. Then my friend Dr. Saravana Pandian, Professor and Head NRM, Horticulture College and Research Institute, Trichy. Then Dr. Kannan, PG Coordinator, and Dr. Prabhakaran, Dr. Christy Nirmala Mary. Then Head of the Departments of Soil Science, who joined online mainly from the TNA Coimbatore, then ADS and Trichy, Pilikulam, then other faculties and students who joined online and offline. Good afternoon, everyone. So we know very well the Tamil Nadu Agriculture University is implementing a lot of developmental program for the benefit of our students. Our Honorable Vice Chancellor Madam is showing keen interest for the well-being of our students. In most of the meetings, Madam will always express, apart from academics, the students should possess the various qualities like soft skills, then leadership and other entrepreneur skills in order to make our students market ready. So in this context, our university is offering a lot of co-curricular program for the betterment of our students. So after the COVID program, COVID, then our university has decided to undertake our PhD Viva OC in a physical mode. And after completion of PhD Viva OC, then the external examiner is expected to offer the guest lecture. So the main purpose of offering guest lecture is that the students will get new perspective and opinion, sometimes which may not be got in the regular classes. And in the guest lecture, student will be normally exposed for the better opportunity to learn about an explicit topic. And further, the guest lecture will provide a base platform wherein the students, then staff and our guest speaker, they can have a free interaction. So for this purpose only mostly we organize the guest lecture. So today we have a guest speaker, Dr. Byju from CTCRI. I understand that he is working on the tuber crops for the quite number of years. So he has developed expertise on these crops. So definitely his lecture will be useful for the not only students and also for our faculty to decide their future path of their research. So in this context, I request all the students and the staff members to have interaction with our guest speaker and make this program as a successful program. So on behalf of AC and RI Madurai, I wholeheartedly welcome our guest speaker, Dr. Byju sir, Principal Scientist and Director CTCR. So with this brief introductory remarks, so I welcome our guest speaker to offer his special lecture on this specific topic.
Good afternoon, respected deans of different faculties of Agricultural University, respected professors, other faculties and dear students. So first of all, I thank the Tamil Nadu Agricultural University and this college for giving me an opportunity to talk to you for a few minutes about a topic on tuber crops and food security and climate change. So, as our professional head Dr. Dean has informed, I am working in the area of tuber crops for the last 30 years, since 1993, in the same institute at CTCRI Thiruvananthapuram, and in between I worked in Bhubaneswar also. Bhubaneswar, in Odisha, we have a regional center, so there I worked for 3 years. So most of my research work was concentrated in 2 or 3 major aspects. One was developing site-specific nutrient management for the different tuber crops. Tuber crops include a dozen crops: waterleaf, tapioca, sweet potato, taro, elephant foot yam, arrowheads. A number of crops are there. So I have developed a site-specific nutrient management using different computer models, especially vectors model, and we have calibrated and validated the SSNM recommendations for the entire tuber crop growing areas in our country. And another major area where I have been working for the last 15 years is climate modeling studies. Today's talk is on what is the importance of tuber crops in future with respect to the changing climate. So this slide is more than a page old, so that's why my designation is given as President. Last January 23, I was selected and joined as Director of CTCRI. My talk is aligned in 4 major aspects. Some of our students are also there. I thought I will make some basic information about food security, what is food security, then climate change, what is climate change, then how it affects crop productivity, and finally, what is the importance of tuber crops with respect to climate change in the fast race. Before 3 o'clock we have to finish also. So we know that we have 17 sustainable development goals, SDGs, that we are supposed to achieve by the year 2030, of which SDG 2, Sustainable Development Goal 2, is very important with regard to the today's topic, that is ending hunger, achieving food security, and improve nutrition and promote sustainable agriculture. The definition of food security I have given just first, and the latest food security definition is the second one. One more aspect is included, that is the term social. So I will read only that food security is achieved when all people at all times have physical access, social access, and economic access to sufficient, safe, and nutritious food, which meets their dietary needs and food preferences for an active and healthy life. So that is the concept of food security. And if anyone is interested to know about the latest aspects of food security and all, we must read this every alternate year. FAO will be publishing this. You can download it. That is the state of food security and nutrition in the world. The latest data and information will be given in this publication, from which I have taken some very important information. That is, in 2020. About 76.8 crores of people faced hunger, and if you see, most of about 41 crores are from Asia. It's a very alarming situation, and this details, and this was in 2019. This was 11.8 crores people more. So compared to 2019, in 2020, the people who faced hunger, 11.8 crore more people faced hunger. So So if you see the prevalence of people that are undernourished in India, we should know that still 14% of the 14% of the people in our country are not well fed, or they are not getting enough nutrition to meet their dietary needs. So these are some basic information. I will skip all these things that will come to my trust. So if you see the major, what are the major drivers of recent food security threats? Some of the major 3-4 drivers are have given, of which climate variability and climate extremes are one of the most important drivers that actually threaten the food security in the world. So we need to now develop food systems. So now the current research is going in the direction. Earlier we were thinking of cropping system. Now later on we were talking about the farming system approach, and of late now it is the concept of food system. We need to develop locally adaptable food systems, that is from once the food from the farm till it reaches the dining table of the, that is farm to fork. So with that concept only now we are working to develop and address these problems of climate change. These are all some basic information. And now I go to climate change. We know that even though the science of climate change is not very old, even during 1780s, during industrial revolution period itself, that started actually the increase in the climate, especially the carbon dioxide concentration. And any information that we relate to climate change, we always compare with the beginning of the industrial revolution, that is around 1850, 1800s. So that is a cutoff date. We say the increase in the global climate has increased by 1.5 degrees Celsius on an average, which means that is in comparison to the pre-industrial revolution period. All this basic information I will leave all these things, what is greenhouse effect. And when we want to know about the latest information on climate change, this is the most important document that we must refer. The publications brought out by IPCC, Intergovernmental Panel on Climate Change, in 2021. Again in 2022 also they have brought out another publication. This is a very huge publication. And coming to the climate change, we all know that with regard to agriculture, there are three major greenhouse gases that contribute to climate change. They are carbon dioxide, second one is methane, and third one is nitrous oxide. These are the three major global gases, greenhouse gases that cause climate change. But if you very critically see in agriculture, nitrous oxide and methane are directly contributing to climate change. Carbon dioxide per se is not much contributing. Due to agriculture, it is not much contributing to climate change. Other gases are not related to agriculture. And when we see this total greenhouse gas emissions before the past, in the past and now, we can see that at least some important information that we can see the last second row. The annual emission, the total world emission is 49, the second last row, 49.36, that was the gigatons of carbon dioxide, the globe totally emitted, of which our contribution is very less, 3.24, but China it is 11.58, US it is 5.83, and if you see the per capita emission, the Indian contribution by an Indian is very, very low compared to many other historical polluters. There are 7 or 8 countries, they are called historical polluters, actually polluted the earth, and that is the main reason for the current state of climate change in our that we are facing. So here again I have given that which countries have actually used up the available carbon budget to keep the world temperature rise to 1.5 degree. The US, European Union, 27 countries, Russia, UK, Japan, Canada, and Australia. They actually contributed, if we take from 1870 to 2019, the last poll of 60% of the contribution is by these 7 countries out of the about 190 countries or so. And Indian contribution is very less, 3.16, China 13, and the rest of the world 22. So the major contribution of greenhouse gas emission global warming is by a few countries, mostly the developed Western and US, European Union, Russia, UK, Japan, Canada, and Australia. These are some basic information. Now, another important point, the students are also here, that's why you must know is the global warming potential. When 1 ton of carbon dioxide and 1 ton of methane and 1 ton of nitrous oxide are emitted into the atmosphere, its ability to increase the atmospheric temperature is not the same. So that is called the global warming potential. So 1 ton of methane, when it is emitted into the atmosphere, actually that causes an increase in atmospheric temperature that is 28 times more than 1 ton of carbon dioxide causes. And it is 265 times more than 1 ton of carbon dioxide causes. So the global warming potential of nitrous oxide is the highest, then methane is the second, carbon dioxide. So carbon dioxide basis, when we say the total carbon dioxide in the increase in the atmosphere, we usually the unit used is carbon dioxide equivalent, CO2e, but small e also will be there. So we will equate carbon dioxide, nitrous oxide, and methane into one scale, and that is the way how we express what is the increase in the concentration of carbon dioxide in the atmosphere. Then which are the major contributors of greenhouse gas? If you see the green portion, that is agriculture, forestry, and land use, contribute to 18.4% of the total greenhouse gas emission in the atmosphere. So the major sector is, we all know, energy sector 73.2%, or road transport and all these sectors. The industry 5%, waste 3.2%. And of course, agriculture, forestry, and land use contribute 18.4% of the total greenhouse gas emissions in the atmosphere. And this is a split up. If you see the annual emission of greenhouse gas in agriculture, forestry, and land use in the world, we can see that 79% is the methane and nitrous oxide emission from crops and livestock. So livestock is a major sector from where methane emission is the source. Then entering fermentation of animals was 2.8%, rice cultivation 0.67%, synthetic fertilizer application, their manufacturing application 0.6%. So this is the contribution of annual greenhouse gas emissions sector-wise in the field of agriculture and allied sectors. And again, if you see the gas-wise, methane, nitrous oxide, carbon dioxide, I have given what is the total kilotons of carbon dioxide emitted through various activities in our country, India. Here again, you can see that the major contributor is entering fermentation, animals, and livestock is the major contributor, maybe followed by rice cultivation, that third one, total concentration of greenhouse gas emission into the atmosphere. Then synthetic fertilizers contribute, manure left on pastures contribute. So these are the major contributors of greenhouse gas emission from agriculture in our country. Source of greenhouse gas and emission and all just giving. Now, carbon emission from agricultural activity, which are the sources we all know. The primary sources are, first one is tillage, excessive tillage will release carbon dioxide into the atmosphere. Then as for sowing, our mechanization, use of machines and all those things. Then harvesting, whatever machines or things we use. Then transport, pumping, water, all these are called primary source. And secondary source include manufacturing fertilizer, right from manufacturing onwards. For producing 1 kg of urea also, there is an equivalent amount of carbon dioxide emitted in the atmosphere. Then packaging, storing fertilizers, pesticides, all these are secondary source. And tertiary source is acquisition of raw materials and fabrication of equipment, farm buildings. So all these contribute actually to greenhouse gas emission. Just an example, in the fertilizer urea production itself, you can see that there is an emission of carbon dioxide in the methane, and in the first step itself, there is an emission of carbon dioxide into the atmosphere. So if we can produce green ammonia, that is the latest concept, from water, air, and solar or wind electricity, the research is going on. That is nitrogen from cryogenic distillation and hydrogen from low temperature electrolysis using renewable electricity. We can reduce ammonia greenhouse gas emission by 91%. So that is such kind of green ammonia production and such kind of urea production is one of the options by which, if we are interested in chemical agriculture, we can reduce the carbon dioxide emission. Then this table, very interesting table, if you just this I have given the global warming potential of different food products. And here just what I wanted to mention here is that most of the plant-based products, any food product, the global warming potential for producing each kg of the product, how much gram of carbon dioxide equivalent is released in the atmosphere. If you see the plant-based products, it is comparatively low, except rice. Compared to animal products, if non-vegetarian, poultry meat, mutton, so all these things emit actually for producing 1 kg carbon dioxide. Global warming potential is very high, and sugar crops also it is comparatively low because they are climate resilient crops. That is a study done by us. It is only 21 gram of carbon dioxide per each kg of cassava produced. And again, this is another unit per hectare basis. If you see the carbon dioxide emission, rice, if it is a continuously flooded rice field, it is about 3,500 to 3,700 kg carbon dioxide equivalent is released from 1 hectare. While you can see the pulses, oil seeds, all these things, the global warming potential is relatively low. This is a lot of work has been done by Dr. Patak, who is the Director General of Indian Council of Agriculture Research, who is a soil scientist, Himanshu Patak. So he has done a lot of work in this area of climate change and its impact on agriculture. Then this is actually the last, not the latest conference of parties. In the last conference of parties in Glasgow, India has committed. These are the 5 major commitments that our Prime Minister has made in Glasgow. This is also related to our work and our research activities. So these are the major commitments. India will increase its non-fossil energy capacity by 500 gigawatts in another 5 or 6 7 years. Then the second commitment that we have made is we will meet 50% of our energy requirement from renewable energy by 2030. And third commitment that we have made is we will reduce our total carbon emission by an amount of 1 million ton. We will reduce by 1 million ton from now till 2030. And also India will reduce the carbon intensity of its economy by 45%. And we have, last one is very important, we have made a commitment that by 2070, our country will achieve a net zero carbon level. Most of the countries have agreed for 2050, but our country, our Prime Minister has accepted, given a commitment that we will achieve net zero carbon capacity by 2070. And these are all some basic information just I will. Now I come to what is the effect of climate change on crop productivity. Most of us know that change in climate actually affects agricultural productivity in many different ways that we can classify into 3 or 4 aspects. Number one is soil resource. Increasing the temperature decreases the surface soil moisture. Then altered precipitation increases soil erosion. These are all affecting the soil resource. Then coming to it again affect the plant resource. Increasing temperature and variable precipitation widen the yield gap and offset positive impact of increased carbon dioxide and plant growth. The increasing carbon dioxide declines protein level. Right? That is a very important observation. When the quality of the produce is reduced due to the increase in the atmospheric carbon dioxide, the global warming, especially the quality of protein qualities, protein content and quality are reduced in legumes, and grain quality of cereals are also compromised. Then field operations, extended wet conditions. There are many cases in states like Kerala and all. Harvesting of paddy is delayed due to unseasonal rainfall and delayed. So all these things are actually really farmers are facing this problem. Extended wet conditions, paddy is getting sprouted in many of the places in Kerala, Palakkad and all. They will not be able to take the paddy due to heavy rainfall. Then disruption of alien species, IAS. Insects and diseases are coming, like, for example, in the case of our crops, tapioca, newly emerged mealybug recently, it's a very serious problem that also attributed to increased temperature effects. Then other major effects, if you see, in C3 crops, it is observed that crop yield will increase by 10 to 20%. That's actually fertilization, while it will be not that much in the case of C4 crops such as maize and sorghum. So this is one major observation. Then the third one, yet the nutritional quality, I have already told all these things, quality. And just you see the wheat, rice, and you can see that by 2100, the climate change impact on crop yield for high emission climate scenario, it is in one of the studies it is observed that the yield of wheat the change will be from +5 to -15. The yield can reduce up to -15% in some locations, while in the case of rice, it is from -5 to -20. So the impact is more for rice and also for wheat. But I will be coming to the impact on tuber crops. Then again, climate change affects the livestock productivity, and the grain yield of rice, for every 1 degree Celsius, there is a 10% increase in the 10% decline in the rice yield for every 1 degree increase in the growing season. So these are all based on number of studies conducted across the globe. I have just compiled the information. Now, the most last part I will come to what is the impact of climate change on tuber crops. Tuber crops actually include a number of crops, including potato, but We have been working on tropical tuber crops, CTCRI, except other than potato, cassava, sweet potato, yams, elephant foot yam, taro, or minor tuber crops like Chinese potato, oleus, then arrowroot. So a dozen crops are there among tropical tuber crops. So they are very important food and nutrition security crops across the globe, especially in African, many of the sub-Saharan African countries, South American countries, Southeast Asian countries, in all these countries around the equator, where poverty is a major problem, undernourishment is a major problem. Tuber crops, especially cassava and yams, they are very important, and they actually is contributing much to the food security and nutrition security of millions of people across the globe. Production of okay, this is about the statistics. Now, if you see the energy production of different crops, tuber crops have the capacity to produce high food energy per hectare per day, per unit area, per unit time. If you see, in the case of cassava, it is 250 kilocalories per hectare per day of food energy to produce. Maize, it is 200. Sweet potato also, it gives 180 kilocalories per hectare per day. That is because the potential productivity of these crops is very high. In the case of cassava or tapioca, the potential productivity is about 100 tons per hectare, 80 to 110 tons per hectare. So compared to many other crops, its the yield potential productivity is very high. Sweet potato is a very short duration crop. In 90 days, it gives a yield of about 20 tons per hectare. So if we take the per hectare per day or basis, and all these tuber crops are very high yielders with respect to food energy. So that is a very important aspect. So they have high energy and nutrient output. Then they have a capacity to survive under dry conditions. That's also very important.
Slides.
So most of these tuber crops, we have conducted a lot of studies, and which also showed that these crops are resilient to climate change compared to other crops. It doesn't mean that the yield will not be affected for these tuber crops. When an increase of 0.5 degree or 1 degree Celsius may cause 5 to 10% yield increase for the case of wheat or rice, in the case of cassava or yams, it will be comparatively less. The impact, the negative impact will be comparatively less. That is what the studies show due to many physiological traits of these crops. So we have conducted some studies on how the impact of climate change will affect tuber crops. I have this is mostly in my lab, in the geoinformatics lab, in CTCRI. We have used a different model, 4 or 5 different climate modeling studies and models are used to understand how the future climate of 2030 or 2050 or 2070 under different scenarios will affect, will influence the yield and productivity of different tropical tuber crops. And this is published in one of the in food security, one of the outstanding journals in food security, which show that in the case of rice, the yield in 2050 the yield can go down by 40%, minus 40, and in the case of cassava, maximum yield can be reduced only up to minus 17%. So all this information very clearly show the climate resilience of tropical tuber crops, especially cassava. Then taro it is minus 28. Rice, the yield can go up to minus 40. Potato also the yield can go up. The last column I have already minus 51. While in the case of other tuber crops, the modeling studies show that their yield reduction will be comparatively lesser compared to other major staple crops. Again, this is another study in which we have made an attempt to understand how the impact of climate change in future climate will affect the suitability in different geographical locations where these crops are grown in our country, major locations. And this is a combination of different studies in the CTCRI. We have studied for different climate scenarios for 2030, 2050, for different RCPs, representative conservation pathways, and most of these studies show that the last column, the overall change in suitability by 2030 is not much, minus 2 to very less. And if you see the impact in other publications of rice, wheat, and all, the impact is comparatively they will be much affected compared to this tuber crop with respect to. So most of the which means that most of the locations where currently now we grow tuber crops will not, the yield is not going to be much affected in 2030 or 2050 also. That is the meaning of this study. Then again, in another study, which is published in Theoretical and Applied Climatology, we have made an attempt to understand the impact of climate change on land suitability of tuber crops with different tuber crops in comparison to rice and potato also. So here again, you can see that in the case of change in land suitability, in the case of cassava, for different RCPs for 2030, 2050, 2070 is given here. Then again, in another study for different locations for cassava, we have studied for Tirunelveli, Salem, and Tamil Nadu, in Andhra Pradesh, how the irrigation requirement will change. So I'm not going to read all these things because we have to finish by 3 o'clock. So water requirement, irrigation requirement, how it will change due to the climate of 2030, 2050, and 2070. In the case of potato, just for comparison, 2 earlier studies show that the global potato yield will come down by 2 to 6% and 9 to 18% without considering, if you don't consider carbon dioxide fertilization. And average global yield will increase from 9 to 20% with adaptation. These are the number of contrasting results are also there with respect to potato. And just one or two slides where I have summarized. One crop I have summarized here. Why cassava is climate smart. If you see the physiology of this crop, you can see that it is highly stomatal sensitivity to change in atmospheric humidity and soil water. Its stomatal grows at a pressure of 1 kilopascal and completes at 4 kilopascal. And the second is very important. It has got a very deeper rooting capacity. Tapioca cassava, its roots will go up to even more than 2 meters depth. And third, it has got an ability to reduce its leaf canopy. Cassava, once it is established, normally it never dies. It will, even with 1 or 2 leaf, even and very heavy drought situation also, it will retain. Leaf, all of the leaves will be shed. So it has got an ability to, and also the leaf size also it will reduce, leaf canopy, so that the water consumption is reduced. Then the fourth point is, it is not considered as C3 or C4. The literature, contrasting literature is also there. But many of the good publications show that cassava is an intermediate pathway of C3 and C4. So it's physiology. So because of that, the C4, C3 intermediate pathway.
Sorry.
Sorry. Because of this intermediate pathway, the net photosynthetic rate is it has got a 15 to 25% of the PEPC activity, and that is also one of the reasons for a higher yield potential and its ability to withstand drought and elevated heat. And number 5 is its radiation use efficiency is very high, 1.6 to 1.9 gram of dry matter per megajoule. Just for comparison, it is 1.2 to 1.5 for rice. And its potential productivity is very high. I told its potential productivity is about 100 tons per hectare. Tapioca is 100 tons per hectare. That is, for that there are many reasons. One is simultaneous development of, it is not a determinate crop like many other crops. It's both its storage organ as well as its physiological part will be simultaneously growing throughout the crop season. Second, it has got a leaf photosynthetic potential and crop growth rate is very high, 23 to 24 grams per square meter per day. Then leaf life is very long, leaf duration, about 2 months. Then sustainable leaf canopy that optimizes photon interception, its leaf arrangement is in such a fashion. Then harvest index is also very high for cassava, 0.5, 0.6. And leaf size reduction I have already told. And finally, it has its water use efficiency is 2.9 gram of dry biomass per kilogram of water transpired. So water use efficiency is also very high. So these are some of the major traits of cassava that is responsible for the climate or resilience of this crop to elevated temperature and drought. Then this I am just leaving. So I am concluding. Climate change brings a cascade of risks from physical impacts to ecosystems, agro-ecosystems, agricultural production, food chains, incomes and trade, with economic, social impacts on livelihoods and food and nutrition security. The people who are projected to suffer the earlier and the worst impacts from climate change are the most vulnerable population, with the livelihoods depending on agriculture sectors are in areas vulnerable to climate change. Then understanding the cascade of risks as well as the vulnerabilities to these risks is key to frame ways to adapt, how we can adapt. Then reducing vulnerabilities is key to reducing the net impacts on food security and nutrition, and also to reducing long-term effects. And fifth point is increasing resilience of food security in the face of climate change calls for multiple interventions from social protection to agricultural practices and risk management. And for the world's poor, adapting to climate change and ensuring food security go hand in hand. That's also very important. So a paradigm shift towards agriculture and food systems that are more resilient, more productive, and more sustainable is required. And in this context, tuber crops have a greater role to play in future, considering their phenotypic plasticity and resilience to climate aberrations. So with this, I am just concluding my very quick presentation on impact of climate change and food security. I'm sorry that I could not, actually I wanted to explain each slide in a very detailed way. It's required 40-45 minutes. Thank you.
Thank you for your comprehensive presentation on the topic. So in the first aspect, you have covered what are the reasons for global warming. Then in the second part, you have covered how global warming affects the crop productivity. It's a nice presentation. So can you show some light on what are the future lines of work that can be useful for our students?
Most, as I told, climate change is going to be one of the most important issues that agriculture is going to face, and we have to develop strategies and technologies. Otherwise, our yield and our food security will be at stake. So there are 2-3 important things that we have to consider. Number one is in the case of breeding new varieties. Now we go for high yielding or disease resistance, or maybe better nutritionally better varieties. So normally breeders will take into account only 1 or 2 traits while selecting the genotypes, by screening genotypes and all. But in the era of climate change, the impacts are many. There are many. So we have to go for developing or selecting genotypes with multiple traits. So we should find new or develop new varieties that will be able to give a higher yield, and at the same time it should be resilient to drought, and also at the same time it should be resistant to some disease. For example, the case of tapioca, cassava mosaic disease. So such kind of multiple traits need to be taken into account while we develop new varieties in future, for which physiological trait-based breeding is one of the aspects that we can think of. In our country also, a lot of, I know TNU also may be doing, I do not know about that. But phenotypic, we call phenotypic, high throughput phenotypic, not only that, sensor-based, a lot of artificial intelligence and Internet of Things based sensors, and so many research work is going on so that you can study the genotypes, attest stretch and understand the physiological traits of the different genotypes simultaneously with the reduced income, labor and expenditure. For example, when we suppose if you are scanning using a drone, you are under the germplasm of cassava. This year we have about 2,000 germplasm. So in one stroke, we should be able to know what is the plant height. We need not have to physically measure the plant height. There are sensors available. Then also leaf area index, or leaf area duration, or canopy temperature. Canopy temperature is a very important factor with respect to climate change. A cooler canopy, a variety with a cooler canopy is more resilient to climate change or drought or elevated temperature compared to another canopy. So if a variety is having a cooler canopy, means its transpiration and things are less. So it is more resistant to temperature or elevated temperature or drought. So that is one aspect. And another second aspect that related to natural resource management is we should actually, I said about the food systems, developing food systems, locally adaptable food systems from the seed till it reaches the dining table. Most of our food that should come from local areas instead of coming from apple coming from USA. If you're interested to eat apple, you have to definitely, you may have to think of that, but otherwise our food system should be locally developed. Based on the food preference, we are even production of value addition, all these things should be based on the locally preferred interest, and we should develop such food systems so that global warming can be reduced to a great extent. And so sustainable production intensification using minimum utilization of external inputs and the maximum recycling of natural resources. So we should depend more on nature and maximum recycling of the nutrients and other resources into the system. So such kind of things should be there. Where comes our organic farming or and natural farming? I do not know. There will be a lot of debates on natural farming. Soil scientists will be criticizing natural farming, but it is coming in a big way. We also has a project on natural farming, and now the scientists are telling that they have some better influence of natural farming on yield and quality, but the science behind it. So all these things need to be understood. So such kind of nature-dependent technologies we need to develop. Sustainable intensification methods, including crop protection, and our dependency on external inputs, chemical inputs, we have to minimize. Otherwise, it is very difficult. For example, in the case of potassium, after the Ukraine war, potassium is a very scarce resource, and in future our country is going to face a very serious problem of potassium deficiency and all. So in such cases, today also we are telling nano potassium, seaweed-based nano potassium DNA is working on. So such kind of newer technologies need to be developed. Then only we will be able to sustain our agricultural production. We will be able to ensure food security, and also at the same time we should be able to protect the humanity, and also we have to protect the earth. That is very important. Protecting the earth is also very important. So, 2 points only as suggested.
The greenhouse gases. So the nitrous oxide is the precursor for ozone, tropospheric ozone. Tropospheric ozone, sir.
Yeah.
So the nitrous oxide is precursor for tropospheric ozone.
Yeah. Tropospheric.
Yeah. So there is any impact toward the CTCR? You have initiated any schemes for the tropospheric ozone?
That kind of studies we have not done.
That's also really interesting.
Yeah, that's also, yes.
And also you explained about the food grain products.
Yeah, global warming.
Cassava, you have shown the global warming potential is very meager.
Our crops it is less.
Why, sir? So you explained some of that climate smart. Rather than that, why it is showing that?
I told you its water requirement is less. Most of its external input requirements are less. It is so we have worked out. There is a tool is the mode tool. So with that tool, when we work out, so even millets also it is less. Pulses also it is less.
Based upon that availability.
Available.
So then one clarification, sir. You explained about the scenario. So then RCP like that. So it was taken from the IPCC.
IPCC assessment report AR5.
Yeah.
They say different scenarios. Representative concentration pathways RCP 2.8, 4.5, 8.5. So in which pathway our country will progress? A high economic development pathway, a medium pathway, a low economic development pathway. If we follow this pathway, what will be the situation? So like that we predict.
Thank you.
Sir, you have explained so many models, sir. Which model is suitable for cassava?
Cassava actually.
Because we are having Etapur, we are having one research station.
Yeah. That is an coordinated sugar crops and also we have collaborative programs with them.
Which model is?
Cassava for nutrient management, I have used the QUEFTS, QEFTS model. QU is a model, that's an NPK. We can work out the NPK requirement for different for yield targets, for different yield targets that we can work out. We calibrate and validate the model that we have done by conducting more than 400 trials throughout the country in Kerala, Tamil Nadu, Andhra Pradesh, and we have calibrated, validated for different agroecological units and zones. Now we have recommendations. So that is found to increase the yield by 18 to 23% compared to our recommendation. Mostly it is due to the interaction effect because related to the study of disease. So interaction will be taken into account in these models. Interactions will be taken.
Nutrient.
In STSCR also we are not taking into account interactions. But in this kind of models, they take into account nutrient interactions.
Any questions from students?
Students?
Online level.
question from online. Online people can ask the question.
I thank the Dean SPGS for permitting us to conduct this lecture. I also thank our Dean AC Madurai for his continuous support and cooperation for conducting this guest lecture. I thank our professor in the Department of Science and Environment for his continuous effort to conduct this guest lecture in a grand manner. And also I thank the Dr. Saravana Pandey who has come from the Horticulture College, Trichy. And also I thank all our faculty members for their cooperation. And also I thank all the students that have come from the other departments as well as our department. I thank our guest, Dr. Byju, he has come from the Thiruvananthapuram, that is Indian Tuber Crops Research Institute. We are highly thankful to you, sir. He has given a very comprehensive lecture on the tuber crops in relation to that. This is climate change. So the climate change is not going to affect the tuber crops very much when compared to the other crops. So we can go for tuber crops. Thank you, one and all. Thank you.